Cool. Welcome to the Veritas Automata Deep Dive podcast. We've got Saurabh, we've got our friend Crichton with us, and we've got myself, Ben Savage, the founder and CEO of Veritas Automata. Um, Today, we're going to talk about vibe coding slash AI assisted development because I don't think any of us are millennials and we can really call it vibe coding and what we think about it and what our experiences have been, and maybe some of the things from a risk perspective people need to take into account. Um, I can say that everything I've tried with it so far has successfully failed to actually run, but it's failed in unique and interesting ways.
Yeah.
I think you guys have maybe had more success than I did.
I've had success in doing smaller programs. Like in essence, like if I can define it really, really well, it does well. But it really, really struggles with basic things like library, picking the right libraries and versions that are compatible. Definitely does not understand boundaries of systems. Like if you are defining a single app, yes. If you're trying to actually wire something together, it right now it does not have the capability to understand the context of anything large.
Yeah, especially with smaller model, because the context size is so small, it loses context if your project is beyond one or two different files, and if it's splitting on back end and front end, then good luck. So the libraries one, I also ran into it because it uses like a couple of years older data to train because you're going off the internet, right? And then you would refer a function that has not been used anymore, and you are like running into problem. What is this?
I found something slightly different.
Yeah?
It's interesting. Yes, it'll absolutely reference tons of functions but it's with it. It is the older data. It's hallucinating on anything new.
It's making up new functions.
It's completely like it knows that these libraries exist to do these things, but it doesn't have enough code to actually understand it. So virtually every library that's within that has came out within the last couple of years, in essence, it will hallucinate nonstop. It is quite actually amusing.
If you've used any of the thinking model, you can see that happen. Probably this is they have done it this way. You will see some of that blurb go through real fast in one of those O1 models or any of that. And I'm like, okay, he's trying to guess what the next version of the model is going to look like, or the library is going to look like, and come up with his own theory kind of thing.
But I think that's also some of that hallucination is where some of the security risk is, right? There was a couple articles earlier this week where they were talking about because they hallucinate, now there are new libraries that someone could inject a bad package into a repository, which is kind of terrifying.
Yeah, the hallucination on the actual names of packages is frightening because obviously, like, if it's consistent enough, they will target those type of things.
Yeah. Beyond that, what I was thinking is hallucination. It probably already started. They're injecting names, bad actors, into the web. They're strategically distributing it through Slack chat. Oh, I found an answer. This is this. They use this library, and those LLMs going to pick up on that. Hey, this is not working. Try this library. This is a new one, up and coming.
Ooh, that's actually frightening.
Yeah.
You know that they're doing that. Like you can sure.
Yeah.
Like that's the.
So let's talk through the tools we've used, because like I've used Continue, which is a plugin for VS Code, and I can use that with Olama, so I can use that with local models.
Right.
And then I've played with Cursor, which has their own model and all that. So what tools have you played with, Saurabh?
I have been directly on the LLM without using any tools because I like the control on, how do I kind of control. So I've been using ChatGPT and some of the local ones, R1 especially. I really found that the thinking models are much better at coding than the non-thinking one. There's, like an R1, DeepSeek R1 or the O1 series, the O1 Mini, O1 High. Perplexity has its own and Claude has its own. The thinking ones, right? They do much better than completion one. That's what I found. A slight deviation of some complexity and it falls apart very quickly.
Yeah. I mean, for me, the two best models I've played with are the large context models, which are like the newest Llama and OpenAI's.
Because you were doing a lot with Copilot, right?
But I've been doing a lot with Copilot. But the issue with Copilot is that it's very good at a function.
Yeah. Yes. Yeah.
And maybe a file, but even there, it has a tendency to hallucinate more. Like it's
Yeah.
interesting that you really, like this is one of those things of, it's almost not prompt engineering so much as almost pseudocode, how you have to explain things.
No, because I'm with you. Because like the one error on the most recent one I was trying, I suspect is a operating system compatibility issue. Because I prompted it. Because what I tend to do is say, here are the requirements. Like have a requirements file. Here's a set of tests, and then I prompted it with, I need this to run on Mac OS X.
Right. Yeah.
And I'm getting I think it's an x86 versus like ARM error, which tells me it's probably using a package from somewhere wrong.
Correct, yeah.
It's expecting an x86, not one of the new M3s. But I told it was using OS X. Now, if I talk to a human, they would know,
right,
we got to think about that. Software's still catching up sometimes.
It is interesting compared to, because I do that a lot. Meaning, like, if I want to actually generate code, I tend to use more than one model to actually put in the prompt to see which one's best, because it varies.
Yeah.
There are things that GitHub Copilot is a lot better at versus like OpenAI. It doesn't hallucinate on the same things. I do think that OpenAI has no concept, in my opinion, of packaging. Like it does, but like a lot of the stuff that we use is new. So I see a lot of, it'll have the package, but the version won't exist.
Yeah.
The functions will be off. But its structure of code is better. Meaning like its logic behind actually like structuring the code it tends to be a lot better than some of the models in Copilot, like depending on what you're actually trying to do.
Well, and some of that I wonder too is where they're getting their training code from.
Yeah.
Because as I think about it, if they're pulling the code from GitHub as their primary repository to train from, there's some good code there. There's a lot of code that is probably not as efficient or well designed as most people would like because of the nature of the kind of projects that are there that they're going to be able to train on. I wonder if that impacts why you get different behavior from some of the models, or would it be more of like a human feedback kind of?
I think some of it's the thinking models have a tendency to play more to structure.
Yeah.
In a way versus, I don't know, like, I don't know. I don't know what makes them different. I will say, like, I like OpenAI's structure of code, like the way it actually tries to organize things. I do not like some of the other models.
Yeah.
So how do you guys actually interact with these models? Are you just giving it a prompt and like a very detailed prompt saying to build a specific function, or are you writing like more detailed sets of requirements and other criteria that you feed in addition to the prompts?
I got success when I follow a structure like, here's what I want to do. And instead of writing code, I explicitly say that don't write code, write how you're going to do it first. And then on a secondary note, and now start building function, step 1, step 2, step 3, and not build the entire thing together. I've seen that to be much more cohesive when the code comes out, rather than, hey, build me this, here's my requirement, then it goes hallucinates and goes in different direction. Because it's ultimately, if you look at LLMs, it's always a dice roll, right? Which path's going to take it based on probabilistic sampling, right? But so when you tell them to set up your pseudocode kind of like the logical flow, and then attack step 1, step 2, step 3, and then it knows what it wrote in, so it can hold the context better. I've seen that to be less buggy.
At what point is it just faster to write the
code? I think if you are doing something mundane, that's when I use it more of. I've tried using the complex problem solving. It takes way more time to do it through that, but versus me doing it. But again, if you're looking at somebody, let's say junior, trying to solve a harder problem, maybe that is a good guide to have to kind of whittle through and think through all of these stuff, right? So the other thing I've also seen is, when the code comes out, you can refeed the code and say, can you optimize that? You can run that a few times, and it really can shrink that code and kind of come up with some ideas.
It's kind of like the 5 whys of lean, right? You ask why 5 times, and the 5th time you get the right answer.
Yeah, often
I do that through other models. Even like basically, you take the code that was generated from one model, you put it in here, and like, can you improve this? That's good. like your idea of actually asking it to step through its logic, like its thought process, and then generate the functions. I have not done that. I have a tendency to actually, like, I'll start with, because I like the way certain things structured, with a very high level thing of an entire project,
Okay.
and say, generate me a zip file
Mm-hmm.
of this project through OpenAI. Then I'll bring it into to Copilot, and in essence work at a function level. But I will admit, like, if I know how to code the function, it is better, speed wise, it's better to do that than to figure out how to describe it well enough for it to generate the code.
Yeah, because the approach I was taking was a little different. Because I was trying to have it generate a whole program, and this is particularly I've tried it both with Cursor and with Continue. Cursor is a little easier to do it. Cursor is easier to go do it because I can just do it all in one thing. Because it will create more things.
Mm-hmm.
You have Continue, I think, would be better for the function approach, in particular if you had code, because you can do something and ask it to go do it. But what I'll do is work with an LLM outside of whatever tool I'm using and say, here's the requirements. And then I'll try and do what are the acceptance criteria.
Mm-hmm.
And then maybe even what are some high level acceptance tests. And then I'll feed those 3 files in and say, can you generate the code?
Yeah.
And what I also try and do is give it some focus on a language. I tend to, the common ones like Python or TypeScript, JavaScript. I'm not going to ask it to do something really weird like Pascal or something, because it's not going to. Where's it going to get the data?
I will say, and this is a hint, like, I do think that this is going to shift code to typed. And I'm not, like, my favorite language is actually Lisp, but like, because what I found is because of the hallucinations, type languages catch that at compile time. Python and JavaScript, it's a lot harder to debug because you have to actually run it to the point it fails. Versus, like, in essence, TypeScript, which is what I've generated most of the stuff in, tends to actually capture at least the package problem issues that we see. And that is a bulk. I will say debugging these programs is not easy because when it's written by a person, it's almost predictable where it's going to fail because the easy stuff doesn't, or things like the library stuff hallucinate. But hallucinations can happen anywhere, and it's really hard to sort of, it's not the program has a logical problem that you can see. It's some other type of weird thing that you have to dive into.
Well, and that was another article I saw recently where they're talking about, like, these tools are okay-ish at generating code. They're not good at debugging yet. Not really.
No.
Yeah, I did something funny, linked up when it made it generate the code, automatically run it, send the error back, and it burned through a lot of my ChatGPT credits in looping around.
Oh, you made a feedback loop. That's actually cool.
No, it went into a Goldberg machine. He was trying to patch on a patch, and I'm like, huh?
That's actually mildly fascinating.
Yeah,
This is why you don't give AI.
If you can actually output the type errors,
and
feed it back through on a type system, it could probably correct fairly quickly the hallucinations around libraries. Because again, things like Cursor could do that because once it has like the library interface, like if it's being fed in the actual like almost AST, it should be able to detect it and be able to know what functions that library has once it's imported.
Well, and I think there are probably going to be some things that come along that help. Like, I know Cursor has a bunch of like config and other things you can do to guide it to use specific libraries and things. But that's also where some of the security vulnerabilities are coming from, because in that and in the prompts, you can use Unicode to inject what to your computer looks like characters you can't see. It doesn't render them, but the LLM interprets it as always go have it call back to a specific URL or whatever it does. So I know there's a lot of configuration there. So I think that's going to be an interesting it's kind of the hard thing for a lot of dev teams, right? How do you create what your coding standards are and make sure everybody actually follows it, whether it's libraries or tools or other things?
Yeah, I mean, definitely. I mean, the three of us have discussed quite a few times is that AI generated code opens up a whole nother level of threat vectors that I don't think we've even come close to figuring out yet. Just like it doesn't operate exactly like a person, or it's grabbing from code that in general isn't secure, never meant to be secure.
Yeah.
So for commercial, like, because it's not generally using commercial code to train these models.
And that makes me think if you get a whole other thing, like if it starts pulling a whole bunch of weird GPL3, GPL code and putting elements of that into your code, how do you even know it?
Well, that's the thing that worries me the most sometimes is like how there's no way to know that stuff. Now, in theory, things like Copilot and OpenAI have a concept of understanding the license structure to try to avoid that. But like OpenAI, like there's no way to tell it to avoid that. Whereas Copilot, you can. Copilot, you can actually set it up to not use basically GPL3 and other code to actually generate code. It's a little like, I haven't seen it actually affect quality, but it's definitely something that you kind of have to do sometimes.
I think it has to be like a downstream, like something that checks the code. Maybe the license is fine on the base library you're using, but it is importing another library which may have a problematic license, right? Going down that tier of all the libraries.
Oh, I'm more worried about the code it generates.
Well, yeah,
not the libraries it's bringing in. The libraries bringing in, I can check.
Yeah.
I can't check the code it generated.
Yeah.
If it pulled it and it's almost verbatim. Like this is the same problem that it has with creative stuff.
Yeah.
Like in essence, this code is copyrighted that was used to generate it. Like to generate the LLMs. Like while you hope that it is more in the thinking stage, like it's actually trying to figure it out, but we know deep down, like it's a differential engine. Like it's
well, there's a whole other thing on licensing on that. That's all the content I've got in these LLMs, right? They've maybe taken liberties.
I don't even think the world's prepared for the liberties that were taken.
Yeah. But let's staying on the code.
Yeah.
Saurabh, you were talking about something as we were getting ready for the podcast, just about the efficiency of the code it writes and how fast it can program something. So you want to talk about that example? For the customer, we can't go into too many details, but you can talk about the 2 days versus.
So I was doing some kind of image-based processing, and it was processing the video, doing certain things, and I tried to use vibe code on it because it seemed simple enough to do it, So and it kept on running, and we are using A6000 GPUs, which made no sense to me. It's like, why is it taking so long?
So you created a job that took 2 days on a pair of A6000s,
Correct,
which is 96 gigs of video RAM.
Exactly. I was like, what's going on? And I thought it was some kind of a bottleneck happening, something is slowing down, because it was very fast in the early on, and then it kept on slowing down and down. And, so I at that point, let me take a look what it did. And what I figured out, since it was imaging, it was series of images, and every time you would process a nth image, it would go through all of the n first, and then pick up the n and then process it. So essentially, you're exponentially increasing the load on it. And it was like, why would you do that kind of a thing, right? So you wouldn't catch that unless you are going line by line, looking at it, and then that defeats the purpose of vibe coding. You want to automate the code, right? So
I am glad though that we had a pet GPU server to run it on. So
that's right. Burn through learn. Yeah.
Well, just think of if it had more capacity, would it have grabbed more GPUs? What would it have done?
Yeah. I mean, it begs the question: does it makes vibe coding obsolete or not a useful thing? Probably not. But
I think it's early.
Yes, it's very, very early. And if it is fitted with proper upstream code as well as downstream code to kind of contain it, that it's not going crazy while they were doing things, right? For example, with any of the reasoning model or even the generative model, you can do a chain of thought. you must follow these steps before you produce a code. That's a chain of thought sequence, right?
That's that pseudocode. In
Yeah.
essence, like you're telling it
Yeah.
approximately what it needs to do from an algorithm
Right.
standpoint, and saying generate. You're basically translating it into this language.
I see a parallel with my kids. So they love to do maths mentally. Give them a problem, they are thinking about, here's the answer. I'm like, no, show me these steps. I see the same thing with LLM. They'll just want to go to the end of the product, produce the code without, showing the entire work, right? So, sometimes the LLM wouldn't follow the chain of thought, but sometimes they would. But having that rigor, right? Did you go through this? Did you check box all of these things?
I think some of it too is how do you expand these tools so they're not just looking at the code?
Right.
And I was talking with one of you about it, but it's like, how do we basically do a RAG? So it's like using our corporate code base to start. Because we know that's going to have some of that. And then how do you have other standards and the other requirements? So when someone's prompting it, it has more knowledge. And that's kind of why I was playing with Cursor. Because I think Cursor has some of that.
Yeah.
I wish there was a way, and this is something that, like, mentally, that, like, I want there for microservices. Like, here's a perfect example. Generally, you can define specifics, but the dependencies on other services that you do, like being able to feed in the actual architecture of the systems along with swaggers, endpoints, and everything as part of the prompt before, to say, these are what you have the services, basically your service registry, to be able to say, okay, here's all the services you have, and then describe the problem. That, I think, could actually work. I do think vibe coding speeds things up. I'll take an example. Like recently, like that device conduit thing that we were building, which is basically just a thing that basically moves messages around. But it's fairly complex. In essence, like, to me, it would have taken weeks and weeks, but I was able to get something functional fairly quickly. Though I had to write a lot of the code, a lot of the boilerplate and all of that stuff was generated fairly quickly, in which case, what's interesting, it wasn't the logic of what I was doing where I struggled. It was in something like bringing in open telemetry, because it's so new. I probably spent at least 50% of my time not on the logic of the system, but on getting open telemetry to work properly. And when I say open telemetry, this thing actually was trying to transcribe open telemetry through a message protocol thing. So it did involve some way more than just a normal sort of open telemetry setup. But because the structures were so new, it was a lot of trial and error. And less like it hallucinated a whole heck of a lot more on that stuff. And I in essence, I had to go read the code.
And I think that's going to be harder and harder for some to do, because some of this, you got so much helpful stuff from Stack Overflow, but because people are now using AI to go help them, they're not putting the same questions in Stack Overflow. So is there a point where, as you get to this newer stuff, it becomes the AI can't do as much because it doesn't know where to go find the answer?
Right. Oh, I think the whole feedback loop and the fact how AI is changing content, particularly around code and other things, that feedback loop is drastically going to, in essence, deteriorate like the upper bounds
of what the AI can do.
Like in essence, it's one thing if it's learning from people. It's another thing if it's a feedback loop on itself. As we've seen, like almost all like machine learning systems, that's a problem. In essence, you end up that feedback loop deteriorates the quality. Like figuring out how to filter that stuff out is going to be a challenge for, the companies that are deep into this.
No, that's very much so. And I think the other thing is, everyone's talking about it's going to replace developers, and I think it's going to change developers. But everything we're saying there and what we were just talking about is you're going to need those high-end developers when you're doing something new or getting to some of that, because someone who's just used AI won't be able to troubleshoot it.
This is the biggest challenge that I see with AI is what it's doing to the industry is you absolutely are still going to need the individuals at the top because they are the ones that can debug these things. They are the ones that can understand, conceptualize, and actually design at a level. But the industry is basically gutting juniors. But the problem is this group's going to age out.
Yeah.
What happens when they age out and there's nobody to take their place? Because that is the thing that scares me the most.
So I'll ask a counter question. Is there a possibility there are too many juniors too many juniors and mids, because they went through boot camps and they learned how to do a lot of basics, but they didn't learn some of the hard parts about programming and engineering?
Maybe. But my issue is that it's fine if we can figure out how to keep some of the pipeline.
Mhm.
But if we can't if the pipeline falls apart because there's simply not enough jobs for those, or there are not enough companies that understand apprenticeship systems, which I think is what we're going to have to move to.
Yeah, I think
that is one of those things where we are, as an industry, we have to figure that out.
But I think we want to be clear too, when we're talking about senior and mid, that does not mean we're talking about people with only college degrees. There's a lot of different ways.
No, not even.
There's a ton of different ways to get into people who get into programming and how they make that curve. But some of it's what you talked about for apprenticeship, right? They're working with people who are saying, here's how you architect, here's how you do this complex piece that maybe someone in school hadn't even seen before.
Yeah, no, I honestly believe that software engineering is something that is taught better in apprenticeships thing than in a school setting. Now, granted, I mean, obviously, my degrees are in mathematics, computer science, and stuff. So, but the two best programmers that I know, one came in with an art degree, and the other one no degree at all. Like they were just a math nerd.
I knew a guy like that on a project I worked on that when I was a consultant. He was like a Russian lit major, but was a super good developer. I, on the other hand, don't have the degrees, and I'm really good at making programs that don't work, which is why I work with you guys. I can figure out the high level idea, and then beyond that, I'm dangerous.
Yeah, but see, I can design any computer system, but getting my phone to do what I want sends me over the edge.
It's just Siri. It's trying to help. Or if you're using Google, whatever it is.
I wish it was just that. I have learned that I am very good at designing computer systems and UIs and stuff like that, simply because I need things to be intuitive. I have a need. If it's not intuitive, I get frustrated very quickly. It's not that I can't figure it out. I just get frustrated.
So would you describe AI as intuitive or a complete cluster at the moment?
It's somewhere in between. I think I'm amazed at how getting started on a project, how intuitive it is to talk to one of these LLMs, get sort of started. I think it gets way more clunky when we're talking about existing code, or when you're actually have like part of the system built and you're trying to debug it or trying to add things to it. That's where I'm like, it's not just not intuitive, it almost impedes you sometimes, because it'll try to make things up.
Yeah.
And that's the scary part.
To add to your scary part, there is a thought that, coding right now is instruction set, right? What if we replace the entire code with a neural network, which is trained by another AI? You know all the inputs and the output. You don't know anything about the black box, what's happening, because you could have a lot of that talk to this API, talk to that API, generatively being done by a neural network.
Well, this is the thing that we've been talking about for a while. Like, my belief is that even in agent systems, it's about taking LLM, generating code, and then that code is what's running. Like the security thing that you sent over, like the idea of being able to have that step where you actually have code you can validate and test.
Yeah.
So
before
that was,
you let it go, that is, yeah.
And I'm blanking on the name of it, but there was a new paper from DeepSeek from Google about using tools to like virtually test the code before it was running, and it was working to prevent a lot of these prompt injection. We'll make sure to include a link to it when we post this.
That was a great
but it was an interesting paper because it was talking about like, you're going to have to think about this, and some of it's kind of similar to what we've done even with normal LLM stuff. You've got to intercept it before it gets to the LLM,
right,
because if you can't have the LLM police itself.
I was going in a little bit different direction. If you
Wow.
recall, a couple of weeks or months ago, there was a code released by somebody who made a neural network that played Doom,
Yeah.
the game, the simulation that has not been written. There's no like
Well, there's
pixels
two.
defined.
That was Google, and then Microsoft just did one that was playing Quake 2 and generating.
It's
in
not
real
the
time.
Quake. The game interface itself is completely generated in
Yeah.
real time. As you put input, it's changing the camera view without having any of the geometry,
Oh.
Unity, nothing.
Yeah, no, I'll send you the.
So
Quake.
he basically.
So he
That's-
did. So that was a diffusion based on Doom, and
Yeah.
that didn't run like full frame. That was running like 5 or 6 frames a second. It was kind of
Yeah.
slow. The Quake one, if you didn't see what Microsoft did,
Mhm.
is running 1520.
Yeah,
It's like you can navigate it. It's like if you played laggy Quake
Yeah.
when we were
Yeah.
in school. Yeah.
Yeah.
It was like playing it over a modem connection.
Yeah.
Ever did that?
Imagine
Actually,
that.
that makes. It's very interesting in the fact that combined with some of the new rendering
Yeah.
techniques, which are in essence using neural networks to basically get around the idea of ray tracing, so that they can do almost real, like super realistic
Think of
things.
front
Like,
end.
in essence, you only need about 10% of the data
Yeah.
to do that
Yeah.
compared to what you need for like a ray tracer and stuff like that.
Yeah.
But like if you could do that and focus your time on the actual game logic and
Yeah.
interaction, that can actually be really cool.
It would.
Well, we've kind of strayed off of what we were talking about. So as many of our conversations do. So Saurabh, what are your closing thoughts on AI assisted coding?
I think it's cool. It helped me learn a couple of new languages just by playing with it. So I think it's going to evolve over the time. It's going to be more of a sidekick rather than a replacement to kind of accelerate a lot of those grunt work out of the way.
Okay, so now I'm curious, what languages are you having it show?
React. I've been looking at front end these days. So, I'm like, I hate front end, but then I'm like, what's the point of doing that? But, so.
I thought you were going to say like Lisp or Clojure or Go. Or
No, I know those
Rust.
languages which are behind the scene, like background one. I wanted to get a stab at the whole artistic side of the things. There's a tool called Lovable, right, where you write a description, it builds the whole thing for you. That kind of piqued my curiosity, like how are they doing this? So, I learned about React, but not reading a single book on React, and so it was cool. But so I think it's a useful tool in the arsenal of a coder, but definitely not a replacement at this stage.
So great.
I definitely think it's a useful tool. In fact, I've trained all my teams to actually use it. I do have significant concerns on the security front and significant concerns on just its impact on the industry as a whole being long-term viable. Like it's just like there are some fears there of things are moving so fast, we're not able to adapt fast enough that it's like, is things going to start crumbling only because we've made the system unstable that supports it, even like things like the feedback loop and just losing junior engineers, those type of things.
No, I'm with you. And what I would say is my perspective is it's early days. I think we haven't figured it all out yet. I think we're going to have to be prepared for it to evolve and change. And it's going to drive things like, how do we create an apprenticeship program to keep juniors there? And it may not be in the languages people think, right? It may be that we need them in some of the legacy languages. Like we do a lot with embedded hardware. People are going to have to know hardware. And some of that's going to still require going to school and getting your EE degree, or your electrical engineering or your computer science in some of those cases. It's going to require having programs to teach people and help them grow through all that, because the reality is, while we were joking about someone catching their GPU on fire, that happens a lot when you're doing some of that stuff. So how do you create those paths where it's safe for people to learn and grow, so that when you get to what you were talking about, the big system, they can go troubleshoot through it? Because the other day I was just dealing with a team who they don't really know the OSI stack, the network stack, and they were telling me something was failing and it was hardware. It's like, no, it can't. Hardware can't fail that way because it can't selectively just let certain protocols through. It's higher up in the stack. But I was dealing with guys who were cloud guys who knew the 100-foot level, but they didn't know the networking level. So when it didn't work at the level they were expecting, they went, it's hardware.
Yeah. I do think one area that AI is always going to struggle in is in that interface between human and machine, which I know sounds weird. It's the ergonomics. It's both UI design, physical systems, those type of things, like, because it's not human. Like, it doesn't matter how smart it gets.
Well, and it doesn't think. It just takes stuff that's out there.
I'm not sure. I'm still not totally convinced it doesn't do it. We are the same. Like how we actually do it. Like, we just have a feedback and a much larger context.
Yeah.
Much larger.
I can almost, maybe. Then no. Oh, cool. Well, Crichton, we appreciate you being here. Everyone, we appreciate you attending, and we're going to wrap the session for today. And I'm sure you will see more interesting podcasts as we continue.